In this video, I'm going to prove proposition 1 using the contradiction method. If r is a real number such that r squared equals 2, then r is irrational. Proof. It is important to note that we can rewrite the conclusion of proposition 1 to read r is not rational. In this form, the appearance of the keyword not now suggests using the contradiction method. So before going forward, let us denote this statement by B and the statement r squared equals 2 by A. Therefore, using contradiction method, we have A, which is r squared equals 2, and not B, which is r is not B would be r is not irrational, which means r is rational. Okay, so also to make it easier to work with, I denoted by A1. Our statement note B by A1. A contradiction must now be reached using this information. Okay. Before going forward, let me remind you a definition of a real number. A real number R is rational if and only if R can be expressed as a ratio of two integers p and q, with q not equal to 0, and as we said, p and q are integers. So this is definition of a rational number. Okay, so working forward from A1 and using definition 1, we can state that R equals P over Q, and Q is non-zero, and P and Q belong to integers. Okay, so a crucial observation here really helps. It is possible to assume that P and Q have no common divisor. Okay, let me write it as and P and Q have no common divisor. What it means? It means that there is no integer that divides both P and Q. Even if they did have common divisor, then this number could be cancelled from both P and Q. So it's not a problem. It's okay to assume that P and Q have no common divisor. Okay, so now we will try to reach a contradiction. What can we do? Let us square both sides of the last equality. So let's say r squared equals p squared over q squared. Okay. Now, also, what do we know? We also know that r squared equals 2 from statement A. So these two statements tells us that p squared over q squared equals 2. Okay, Now let us do some algebraic manipulations and to reach the desired contradiction. Right. Okay. So what can we do? We can multiply both sides of the last equation by q squared. So we get p squared equals 2q squared. Okay, now let us stop and look at this equation. What does it mean? P squared equals 2q squared. It means that p squared is even, right? So this means that p squared is even. P squared is even means when p is an integer number and p squared is even, it means that p is even. Okay, so if p is even, we can write it down as this statement. P is even means like p equals 2k, where k is some integer. Okay, if p is even and it looks like 2k, we can substitute 2k into this equation. So p squared, which means 2k squared, it means 4k squared, it is equal to 2q squared. Okay, next, looking at this last equality, I can do more algebraic manipulations. We can divide both sides by 2, so we get 2k squared equals q squared. Okay, again, let us look at this equation and think. What does this equation mean? Okay, this equation means that q squared is also an even number. So this means that q squared is even. Again, if q is integer number and q squared is even, it means q is even. Okay, so what it means now? So it means both p and q are even. And they have the common divisor, which is 2. So, okay, let us think. What did we say at the beginning? What did we assume? We assumed that p and q have no common divisor. Now we have a common divisor and it is 2. So this contradicts our assumption. So this contradicts the assumption that p and q have no common divisor. So, okay, it means that r has to be irrational. So we wanted to prove that if r is a real number, such that r squared equals 2, then r is irrational, and we assume that we do have the first part the condition of the statement that r is a real number such that r squared equals 2, and we assume that r is not irrational, r is rational. And using that information and statement A, that r squared equals 2, we reached contradiction by doing algebraic manipulations. So this means that r is irrational.